So this is 7.2, which is amount of solutions. Okay, that's the amount of solutions in a system of linear equations. Okay, and this means that you know that we had the same situation with linear equations in the second bimester. We can have either one solution, we can have infinitely many solutions, or we can have no solution. Okay, so when we are working with the graphical method, this is super easy to see. Okay, because for instance, let's say we have these two equations. Let's say we have y equals x plus 1, and we have y equals 2x, for instance. Okay, so if we graph this, this is going to be x plus 1, the y-intercept is here, and the slope is 1, so I'm going to move 1 to the right and 1 up. Okay, so this is my first line. Okay, and then I have y equals 2x, which has a y-intercept of 0. Well, remember, of course, if there's no number here, the slope is 1. If there is no number here, the y-intercept is 0. So the second line starts at 0 and it grows by 2 over 1. So it's 1 to the right and 2 up. Okay. Okay, so here I have one solution. Okay. When I have one solution, it means that the system is consistent and independent. Okay. If I have one solution, the system is consistent and independent. Okay. What happens? What happens if I have a system where, for instance, the second equation is x plus 2. Okay, if the system, the second line is x plus 2, this means you know that the first line is going to be the same. It goes through these points. Okay, and x plus 2, the y-intercept is placed at 2, and the slope is also 1. So it goes 1 to the right and 1 up. Okay, these two lines are never ever gonna cross each other. They will never touch. Okay, there is no solution. There is no intersection, so there is no solution. This is what we call a system that is inconsistent. Okay, it's inconsistent. It doesn't make sense because, like, the system itself. Of course, this line makes sense, this line makes sense, but they together as a system, they don't make sense. They are inconsistent. There is no solution. Okay? This is a typical example with the books. Okay? I read one book and I read one book per month. My friend read two books and he reads one book per month. There is no way I'm going to catch him. He will be ahead all the time because he's starting with a higher number and we are reading at the same rate. So there's no point when I'm going to catch him, never. Okay. And the final type is when we have infinitely many solutions, and that happens when? That happens when both equations are the same. But usually that's given like this. Let's imagine I am given, yeah, like minus x plus y equals 1. Okay, this is also an equation. Okay, an equation in two variables is the same, but it's written in a different way. Okay, but if I rewrite this, I isolate y, I will take the x to the other side, so it becomes positive, and in the end, this second equation is going to be also y equals x plus 1. Okay, so if both lines are y equals x plus 1, what happens here is that both are this line. Okay, so this line is there and the other line is on top of it. Okay, so those are two coincident lines. Those are the same line. This is a system which is consistent, but it's dependent. Okay, this is no longer independent, this is dependent. Okay, and this happens when we have infinitely many solutions. Okay, infinitely many solutions. So two lines crossing, one solution, consistent and independent. Two coincident lines, the same line, infinitely many solutions, consistent and dependent. Two parallel lines which never cross each other, no solution, inconsistent. Okay, I'm going to stop recording here.